Okay. So one of you can just unmute and you can just tell me whether you can see the screen, yes or no.
Yes, sir, I can see, sir.
Thank you. Okay, let's begin. So payment design, I have made some lectures on through video and I have shared via. I hope it's fine. And some videos, couple of videos I have just uploaded the screen and I have shared the same thing. Okay. So, I thought of doing Zoom class so that we have interaction between you people. So please don't unmute.
Sir, you only unmute them.
Yeah, I have
You're not
unmuted.
unmuting.
Okay. Now we are discussing with module 3, payment failures, maintenance and evaluation. And we discuss some types of failures which are caused in flexible payment. So in day-to-day life, when you're traveling on roads, you can see these particular failures, but we are unaware like how these particular failures are measured. Okay, so we have a total what you can say, lot of studies have been conducted from centuries together on evaluation of these particular roads. Now how these roads are evaluated, how this evaluation system helps in managing these assets of payment. Okay, so as I was telling you with stat, like we stand second largest in road network, and having this asset, it is very important to uh, manage these particular roads. Okay, so once these are constructed, we always need to maintain these particular payments. Okay, so we have a scientific way of doing this and we are discussing on in this regard. Now module 3, uh, we have just gone through with what are the different failures and how they are measured and all. So today I'll have just a brief discussion on the same. Okay, so this particular maintenance strategy, types of maintenance, I have taken it from IRC 82. Okay, so I'll be sharing this particular PDF and it is freely available in Google. You can search for IRC 82. So this IRC 82 codebook is very important, and it is latest one also. Okay, 2015. So it is the latest code wherein you can go through this particular code and uh, can just see what are the different types of failures and how they are recorded with reference to flexible payment. Okay, so these are from IRC 82 2015. Okay, and in this regard, so I was talking you about different types of failures and what are the factors which are involved in causing deterioration for the payment. And I have discussed some important failures with respect to photographs. Okay, and there are n number of failures which are found on flexible payment. So in module 5 we will be discussing on failures in rigid payment. Okay, so rigid payment we'll be discussing. This is about flexible payment and how we go ahead with the evaluation techniques. What are the different methods for evaluating these payments and all. Okay, so these are some of the very commonly found distresses found on the flexible payment. So with respect to uh, environmental and with respect to the structural distresses, we categorize two types of categories, and we discuss different types of failures. Okay, so here in Kanna and Justo, I think in page number 583, 84, they are given very descriptively in this tabular column. It will be very helpful for you to understand uh, and read for your exam point of view how to uh, take these particular failures and what are the symptoms of the failures. Okay, with respect to this table, you can see types of distresses and symptoms, probable causes why these particular failures are caused on the payment, and what are the possible treatments for the same. So in a line or two, they have mentioned about these different types of failures and symptoms, causes. Okay, you can refer this particular table uh, for exam point of view, and always in exam it will be asked in terms of line diagram. Okay, so you need to explain these concepts with reference to line diagram, and then you need to give the description about how they are caused and what are the probable treatments for the same. Okay, so this small table will help you in a great way to understand about these failures, symptoms, causes, and treatment. So this should be fine for your exam point of view. Those whatever uh, the notes I have shared, that can be used as a reference for you. And I will be sharing 82 also. You can see in depth about how, what is the location of these particular failures, where exactly these failures cause on a flexible payment. Those things you can refer IRC 82, that I'll be sharing as well. Okay. So now further moving ahead, I have explained this flow chart, but still I wanted to explain again, like how this evaluation is carried out. Okay, so payment evaluation, a very important aspect. Like it is divided in functional evaluation and structural evaluation. Now, as I told, whenever you are maintaining these particular payments, so what is functional evaluation is a road or an end user, he can feel those particular distresses. Okay, so as an end user, you can always feel these distresses. So as an end user means when you are traveling on the roads and all, you can feel these distresses in terms of different failures like potholes. If it is there, then you find the undulation on the road. Okay, so it is with respect to surface characteristics of the payment. What I'm telling is functional evaluation, surface characteristics. Okay, then structural evaluation is something to do with how sound the payment is. Okay, so whether it is capable to take up the traffic load coming onto it or not. Okay, that evaluation when you're doing, that is known as structural evaluation. Okay, so need not worry about destructive, non-destructive and all. So if you see the syllabus in functional evaluation, it is mentioned that how we do functional evaluation with respect to visual examination, or with respect to different equipments which are available. Okay, and structural evaluation, they are clearly mentioned with some of the methods how to evaluate this structural evaluation. Okay, so for example, structural evaluation, it can be done through destructive testing and non-destructive testing. So destructive testing means you are taking actual sample from the payment itself. Okay, so you take a core cutting, then you try to evaluate the structural capacity of the payment. Or in non-destructive testing, so you don't disturb the payment, and you go for testing, and you come up with the evaluation form. Now there are a number of methods, like one is BVD studies. So BBD studies stands for Benkelman beam deflection studies, so which is there as a part of our syllabus. And we have one more method which is known as FWD. So FWD stands for falling weight deflectometer. So these are the two major tests which are carried out to know the capacity of a pavement to carry the load. So it is within the pavement. And functional evaluation, which is something on the surface, which is felt by the end user. Okay, so today's lecture will be discussing on few aspects about functional evaluation, like present serviceability index is something or in short it is termed as PSI. Okay, so present serviceability index is a rating wherein you rate a payment through visual examination. Okay, so I'll be just discussing that particular thing now. And payment roughness. Now roughness is something you find unevenness on the roads. Okay, so you find unevenness, undulations on the road, that can be measured through the equipment that is known as pavement roughness, and this can be measured by different equipments. So with the help of some videos through YouTube, I hope we can share these particular things. And then skid resistance. So resistance, frictional resistance between your tire and the pavement. Okay, so that skid resistance, using portable skid resistance value equipment, we can measure the skid resistance value. So these are some of the things which are subjected to functional evaluation. Surface characteristics, structural evaluation within the pavement. Okay, fine. Now, visual examination. Now, what do you understand by visual examination? Now, payment condition, it can be assessed through the basic thing, that is through visual examination. So, what you do in this method is a team of experts, like 3 to 4 persons, who move on the road, either in a vehicle. So if you want to evaluate the flexible payment in terms of hundreds of kilometers, then it is impossible for the experts to walk on the payment. Okay, so if it is running hundreds of kilometers, they'll take a vehicle and move at a speed of 8 to 10 kmph. Okay, and they record the whatever different failures are present on the payment. Or else, if you have certain shorter stretches, then always we can go by walk. Okay, so team of experts, in the sense these persons are experienced in this particular field of like how they know how to evaluate this particular different types of failures. Okay, like we discussed on one failure like crack. So cracks can be different types. Okay, hairline cracks are there, longitudinal cracks are there, we have transverse cracks, we have alligator cracks, we have block cracks. Like that, number of cracks are there. So person need to identify which type of crack it is. So that is very important for us to know. Okay, so a team of experts or experienced person who walk on this particular stretch, if it is a short stretch, and they record these particular distress in a performa. Okay, and they enter these particular distresses like alligator cracking, longitudinal or transverse cracking, bleeding, or different types of failures. They enter these particular failures in a performa. Okay, I'll just show this performa. So this is the performa wherein they go on and enter the data. Okay, so this performer is again taken from IRC 82 2015, wherein it gives the details of the data collection of the whatever the failures are there on the roads through visual surface distress measurement. Okay, so this performer includes name of the road, uh, what road you are taking with the data, chainage from where to where, type of the surface, whether it is different types of road like inflexible pavement, whether it is made up of SDBC or bituminous concrete or different category of road. Okay, then from kilometer to which kilometer, which comes in chainage of the road only, carriageway width, date of observation, what was the weather condition over there, whether the condition of the surface was wet or it was recorded during summer season. Okay, time, all these things will be recorded. Okay, and who is recording this, recorded by, and finally in office, who is it is checking through. Okay, So this is the visual surface distress measurement performer, wherein uh, chainage, and they go on recording in terms of percentage per kilometer. Okay, so this is the visual examination. Very simple. A team of experts, they go on the field, on the road, and they visually examine this particular different types of failures which we discussed. Okay, and they record these particular failures in the data. Then later these data will be processed. Okay, and they'll be giving a rating for this uh, roads. Okay, like in terms of present serviceability index. So as an exam point of view, you can just refer just what is this visual examination and how it is recorded in the form of tabular form. So this is more than sufficient for you. Okay, so if you want to go for in detail collection of data, then this is the performer which is used. Okay, so I'll just tell flexible payment section, name and number of the road if you are giving the number of the roads, chainage of the test section, subsection, type of surface. Okay, then type of crack, if it is having some cracks with the types, what is the size of that particular crack and what is the area of that particular crack, patchwork if it is there, then in terms of meter, what is the patchwork. So patchwork, whatever you do as a maintenance part, that is also considered as one of the failure on the flexible payment. It is a failure. Okay, then potholes, like if you want to go in detail, then you just measure those particular different failures. Okay, so these are the performers, how we take the data from the payments. Now now coming to the road roughness. Now it has been clearly mentioned how we measure the roughness. Roughness, as I told you, roughness is the unevenness present on the road. Okay, so whenever the road is to be maintained, like if I am a contractor, then I construct a particular road, then that road under a 5-year maintenance. So under this 5-year maintenance, I need to check how it is functioning. So if you want to check how it is functioning, then road roughness is one parameter wherein I need to check for the maintenance part. Okay, so one of the important parameter for maintenance strategies is road roughness. Okay, so road roughness is measurement of a functional performance. Okay, we are discussing visual examination is one part, and road roughness with the help of different equipments is the other part. Okay, so measurement of functional performance is very important. So what do you mean by roughness? Roughness in simple terms is a longitudinal deviation of a pavement surface with respect to the true planar surface. Okay, so with respect to the plane surface, longitudinal deviation what are there, that is known as roughness or unevenness. Right? Then why this particular roughness is measured. Okay, so what is the importance of measuring this roughness? Now increase in roughness will always cause discomfort for the vehicles. Okay, then decrease speed, always there is a decreased speed if you have more unevenness surface rather than the plane surface. Then directly this implies increased accident potential. Then vehicle damage is also there. There is always a vehicular operation cost, VOC what we call. There is always an increase in vehicular operation cost. So there are a n number of reason if there is an increase in roughness. Fine. Okay, you can see here the surface geometric features, like this is the planar surface, the perfectly plane surface. Then this is micro texture, then macro texture, mega texture. Then we are worried about this thing, E on the road. E is the unevenness. Okay, then this is the vertical profile. So you have the larger undulation. Then over the large stress, this is known as vertical profile. So this measurement, what you do, that is known as unevenness or the roughness. Okay. So in IRC, it has been mentioned like they have classified the payment roughness profiles with respect to the wavelength and amplitude. I hope you understand what is the wavelength. Wavelength and amplitude is the maximum wave of that particular this thing. Okay, so you need not worry about this parameters like micro texture and all. We are worried about the unevenness, the fourth point. Okay, so they have classified the dimensions of the wavelength. The wavelength of shot is in range of 50 to 5000 mm. Okay, and amplitude of the same wave is 1 to 20. You need not worry about this. Just for your understanding sake, I have put this particular table. Okay, so unevenness, they are classified into short, medium and long. Okay, then importance of payment surface roughness. Okay, so as I was discussing, roughness is an important parameter for evaluation. Okay, it is a very important unit in payment management and maintenance system in deciding uh, the different strategies for maintenance. Okay, so it helps for a designer like what maintenance strategies to be given, how the present condition of the road is, whether it is serving in a good condition or it is serving in a fair condition. Okay, fair condition, when the maintenance to be applied, and how the budget allocation, fund allocation for those particular roads can be given through the roughness parameter. Okay, you can see as increase in road roughness will always result in higher user cost, either in terms of vehicular cost or damages caused due to accidents. Okay, always increase in road roughness will lead to higher vehicular cost, invites severe criticism, particularly with regard to uncomfortable ride on such roads by the end user, like traveling people. And relationship between VOC, vehicular operating cost, and roughness are well established through several studies. Okay, if you have the increased directly, it is a thumb rule. If you have increased roughness, then it leads to higher vehicular cost. Okay, that's what is been mentioned here. It always increase. The increase in the road roughness will increase in the consumption of fuel. There is a wear and tear of the tires and spare parts. Depreciation cost is there. Travel time is increased, and thus vehicle speed is also decreased. Okay, so these are some of the uh, drawbacks if you have the increased roughness. Now coming to the roughness measurement methods. Okay, so how to assess this particular roughness, how to evaluate this roughness, how to measure this unevenness. Okay, so classified into two major groups. One is they are based on the profiles of the road. Systems which are based on the profile of the road are generally termed as profilometric system. Okay, the first one, wherein you can measure the unevenness, those are known as profilometric system. And second one is based on the equipments, wherein with the help of movement of this particular equipments, with the help of suspension system, basically the unevenness can be recorded by the vehicle. Okay, so those are known as response type road roughness measuring systems. Okay, so there are two ways. One is through profilometric system, the other way is through the vehicle mounted suspension system, wherein you can record the unevenness on the roads. Fine. So in India, we usually go for collection of this unevenness or roughness through the response type road roughness measuring system. Okay, I hope you have seen equipment in front of a transportation lab, which is painted with a yellow color, this thing, and you have the single tire to that particular equipment. So that is known as your bump integrator. Okay, and it is one of the response type road roughness measuring system. Okay, so we collect the data through the movement of those vehicle, which is uh, towed by the different vehicle, and it is very cheap compared to other type. So we'll discuss about this system, what it consists, electronic counter and transducer is there. So that will be dealing with in detail when I discuss on that particular equipment. Okay. Okay, fine. And now, road pavement surface roughness or unevenness is measured in terms of, this is the unit for measuring the roughness. It is always recorded in per kilometer. Okay. Yeah. Now, as per the Indian codes or standards, it is expressed unevenness or roughness index. Okay, RI in per kilometer. Per kilometer. Okay. Now this is a table from SP 16 Special Publication 16 2004, wherein they have categorized. These are the different types of surface. In the performa, it was the type of surface, whether it is surface dressing, bituminous concrete, or cement concrete. So these are the different types of surfaces, and this is the condition of road surface. Now, with respect to bituminous concrete, the condition of road surface, when I move this equipment on the road on the wheel path, and I record the unevenness. Okay, 2000 is the per kilometer. So if I get a value of 2000 and less, then it is categorized as good condition of the road. Are you understanding? If I am going to evaluate bituminous concrete with the help of any equipment, okay, and if I get a value of roughness value of 2000 and less, then it is categorized as the condition of that particular road is good. Okay, and if we get a value of 2000 and 3000, then it is average, and if your unevenness is more than 3000, then the condition is said to be poor. Okay, so this is how you evaluate the system or the pavement through the roughness parameter. Okay. Now, as we discussed, the roughness measurement units are the roughness index in per kilometer. Then later, this roughness index will be converted into international roughness index, or it is in short termed as IRI in meter per kilometer or per meter. Okay, you need not worry about this. Just remember the unit of roughness is mm, roughness index in per kilometer. Okay, so, so in this regard, how to evaluate this roughness or unevenness? There are n number of equipments. Okay, so we have something called as Merlin. I'll just show you how this equipment. Can anyone tell me? You can see this Google screen.
Yes, sir.
Now this is the
Yes,
Merlin.
sir.
Merlin is the basic instrument. This machine is also there in with us in our transportation lab. Okay, so you have a tire, and I'll just explain with reference to this. Okay, so you have a tire. Merlin, in short, this is the long form of the Merlin. Merlin is a machine for evaluating roughness utilizing low cost instrument. Okay, so in short, we call it as Merlin. Okay, so yeah, so this is a line diagram for Merlin, wherein we can record the unevenness of the road if the road stretch is short. Okay, so you can't take this particular equipment if your road stretch is kilometers together. If it is very short, say 5 kilometers or 2 kilometers, something like that, then you can use this Merlin instrument. So it is very simple. You have the handle. It is just like a bicycle. Okay, and a evaluator will be standing here, and there is a pure a probe which is which will be connected or uh, connected to surface of the. This is the surface of the pavement, and he goes on pushing this particular equipment. Now unevenness will be recorded with the help of probe. There will be a disturbance to this probe, and this response will be recorded on the chart with the help of pointer. Okay, so it is not there for your syllabus, just I am explaining you. Okay, so you just move this Merlin with the help of this wheel. Any undulations on the road, it will be recorded through the probe, and this response will be recorded via pointer on the chart, and you can record the unevenness. Okay, so this is the most basic equipment for measuring unevenness for short stretches. Fine. So Merlin is one. Then we have there is a short uh, video which I want to play, wherein these are known as Ramdas. Okay, Ramdas are the vehicles wherein you can measure all the distresses via sensors, cameras which are mounted to the vehicle. Okay, so a vehicle which is equipped with all the sensors wherein it records all the failures on the pavement. So this is the most advanced what you can say instrument wherein you can measure the different failures on the road, and different parameters like roughness can also be measured through this uh, equipment. These are known as Ramdas. Okay, I'll just play this video. You can just go through a small video is there.
The streets of Nashville to make your ride smoother. We have images of every 20 feet of pavement in the city of Nashville, so we're able to sit down and actually analyze where we have patching problems, where we have cracking problems, centerline cracking. We're able to actually collect all of the distresses on our roadway infrastructure. The truck with its lasers can measure imperfections on the roads down to a thousandth of an inch. It also takes pictures of the road surface so it can be analyzed for cracks and other problems. The data collected this year will be good for about 2 to 3 years, and Metro can plan which roads will need paving or have cracks sealed sooner. Metro contracts out the work. It's a great way to see a new city, and the crew has not gotten lost on our roads that change names.
Coming from a small town in Pennsylvania, which is where I'm from, to the big city of Nashville, and you are a big city in my book, knowing that I can drive anywhere in the city of Nashville and not get lost says something for a small town boy. It is interesting coming down here, though.
Old Hickory, fella. Right. The crew drives 40 miles a day. The project will take 6 to 8 weeks. Of course, if the roads are wet, that's a day off.
Okay, that is the most advanced, what you can say, uh, way of collecting the data. Okay. So Merlin is one, and then Ramdas we have. Then we have the bump integrator. Bump integrator, as I was telling you, we have this bump integrator in our college itself. It is kept on the corridor of the in front of transportation lab. If you have seen this, so this is the most common equipment wherein in India we are using this, and we do a lot of consultancy with respect to this bump integrator to record the unevenness of major road. Like it is the compulsory test which is required in regard with maintenance. Okay, so if a contractor wants to approve the financial or whatever it is for proceeding with the further financial aspect, you need to carry out this bump integrator studies. So we'll stop here. In the next class, we'll discuss about the fifth wheel bump indicator. What are the exact procedure? How we record this? Okay, what is the procedure of the same? Fine. We'll stop the class here. Now we'll take the discussion. Are you understanding?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Is it fine or
Fine, sir. Fantastic, sir. Good, sir.
now? I felt when I want to show something on internet also, it will be very convenient for me, like videos and all. And I feel it is interesting with respect to payment design, particularly evaluation and all. It is very interesting.
Yes, sir.
Now I want to know any difficulties till now in understanding the concepts, like in problems particularly, whichever are difficult to through uh, internet or online. I have left them there only. We'll be discussing them in the regular class. Okay, so I have not touched this part, but whichever we can understand, which are simple, I have discussed through the video sessions. Yeah, any discussions, like you want to ask something so that we can
No, sir.
So, what about internal, sir?
uh, who is that?
Chetan, sir.
ಚೇತನ. ಏನ್ ಚಿಂತೆ ಮಾಡಬೇಡಪ್ಪ ಚೇತನ. Internals will be there.
Sir. Sir, our problems, sir, our serious हो गए, sir. Our problems कल sir class में available, sir.
Just I'll just reply. Wait.